Okay, hello back. Today, as promised, it's going to be lesson 7. It's a problem statement, knowing some stuff, and let's find the moment. Let me read the problem. You have a system. Pretend that this is, I don't know, like putting a nail here. You want to take it off. You want to see how much moment that you could apply in order to make sure that this is not gonna rotate. Whatever it may be, that's a system. You have arm that's 18 inches, force applied obliquely with an angle of 10. The force magnitude is 200 pound. The distance from the edge of that arm or that side to the point of interest, which is C, is 4 inches, not to scale. The angle between the oblique side and the horizontal is 70. And you're trying to find what is the moment at C. Well, anytime I have a problem like this, let me tell you I would say my mind, set, or the thoughts that I go with. I look and see where I am looking for finding the moment. See, do I have, or how many forces I have? 1. Do I have a nice system or no? What I mean by nice system, is it already perpendicular or is it something like this? Well, I have so many, I would not say complex system, but I would say it's not nice and easy. So the first thing immediately what I would do, I would say I want to do Px and Py. For the force, I want to also do Rx and Ry. And I mean by R is the 18 inches. So this is going to be what? 18 sine 70. And this is going to be like what? 20 or 200, sorry, times cosine 10. 200 sine 10. 18 cosine 70. If I did this, boom, done. Everything should be easy. So let me erase this part. Where's my eraser? Okay. We're looking for a moment at C. Caused by P, obviously. That's a really, I just had a comment. If I have another force, I'm just asking you the moment at C caused by P. Don't worry about the other force. If I say find the moment at C, then you have to count how many forces. And let me just put a note here for myself. Toric versus moment. Just someone asked me yesterday. So sum of the moment at C, well, I need to indicate a reference. Counterclockwise positive, it's going to be the moment at C. I just write this for you. Caused by P. You don't have to say that. You just say MC. Typically it's 0, but if you're looking at moment caused by a force, you put a moment. Remember, like, sum of the forces in the y equals 0, or could be Ry, the resultant in the y direction. And similar with the x. Moment could be a really tough topic, or it could be really easy if you understand it that way. I don't think you should have any problem. But that doesn't mean that you don't practice, no. Practice makes perfect. Put that as a slogan for yourself. And speaking of slogan, we are having some snow tomorrow, so that's exciting. So, you've got Px going to C. Let me do that in red. So you're going from here to there, so you are going to have clockwise moment. So that being said, so you've got minus px times the perpendicular one, which is distance from here to here with the perpendicular. So the perpendicular distance for px is ry. Going from py, we're done with px. Going from py to c, again, you're going clockwise. So that means you've got minus py times rx equal the moment. Or it should be the opposite if you want to say it. To counter that, to just make it like equilibrium. You have 200 pound causing 300 pound inch moment. I have to have opposite of 300 pound inch moment. Otherwise the system is not in equilibrium. And that violates the statics definition. The rest is piece of cake. Minus 200 cosine 10 times ry, 18 sine 70 minus ry is 200 sine 10 times, I don't have to think about it, just from here, 18 cosine 70. As promised, I'm not going to solve the math. So this is the answer for MC. I think I'd solve it having P right there. So, I'm sorry, having this, let's call it A, right there. So that's going to create counterclockwise moment. I've got like 300 or 3,000 something pound inch. But for the drawing that I did, it should be definitely different. Just plug that in your calculator. The way I would probably do it, I will take this out of the equation. So 200 times 18 out, or minus, and then I'm going to have cosine 10 sine 70 minus, or already took minus, cosine 70 sine 10. And if you really like math, you could tell that this is sine, I think, alpha plus beta, if I'm not mistaken. Sine, cosine, cosine, sine. I think that's should be, this thing is going to be sine 80. But we're not doing math, just for the sake of math fun. This is two-dimension moment. It's pretty simple. If you follow this, it should not be a problem. Let me take, I'll see how many minutes I have. I think we are good to go. Let me take 2-3 minutes to talk about three-dimension, and then I will be posting a three-dimension problem. I'm not going to really focus on three-dimension for a moment. Just FYI. So, let me just keep it for a second, so you could pause it if you miss anything. And let me erase it. Before I do three-dimension introduction, I'm going to talk about torsion, torque, and moment couple. A lot of people mix between all of them. They're really confusing. Torque and torsion, both when it comes to twisting. Like you have a shaft, if you're a mechanical engineer, you're applying some torque, twisting. In bridge engineering, if you have like alignment curve bridge, and you have your girder here, you know, something like that, and like girder 1, girder 2, with the braking force, with that old thing, you might have something called torque, which is VQ over IB, but that's not the topic. Torque versus moment is more about twisting versus just perpendicular distance causing, or perpendicular force causing an object to rotate. You have this beam straight, you've got force here, perpendicular, that's moment. You've got twisting, we're trying to open this, for example. You do this, right? But if you're doing this, twisting. just on the side note. Let's talk about three-dimension analysis. Well, I've never used three-dimension moment in my practice or practical life. I typically do just two-dimension analysis. But if you're talking about three-dimension, you've got the moment, three-dimension moment, just for you to not get confused. R cross F. Well, F from chapter 2 is your F times unit vector. R, it's pretty simple. Distance, the vector arm or distance between point of interest, the point of interest, and the initial or final or any point along the force. Initial, final. I'm not going to say any point because that's confusing. You're not going to look at a random point. It's true, but you're not going to do that. Initial point of the force vector. What do I mean by that? Remember the first one of the questions that I gave in chapter 2, or on chapter 2? It was something similar to this, if I'm not mistaken. Right? So if you're looking at this point, the R vector is going to be from here to here, or here to here. So you have one option, option number 1, say A, B, C. Option number 1, from A to B, up to, you've got from A to C. And obviously, clearly, if you are pay 1 second attention, you could say that AC is much easier. Well, this is moment about a point. In three-dimension, you could have moment about an axis. How to do that? It's not that much, significant difference. You've got about an axis. Same thing, moment about that axis. It's not going to be a vector, it's going to be scalar, because you already identified the axis. So you don't say, I am going north, I'm going 30 miles per hour north of this. You already identify it, so your axis is this. So why you want to give also another vector? It's going to be the unit vector of that axis, which is easy, dotted with the same thing. So the only little difference is you're trying to find the unit vector of the axis. So if I'm asking you to find the moment about this axis, what you need to do, same thing, are from here to here, but you also need to dot it with the unit vector of this. And I'll be practicing a question next video. Hopefully it's going to be posted today as well. So we should be good to go for chapter 1, 2, 3. I'll be receiving questions on Wednesday in class. I posted the homework assignment for my students. So check under files on Canvas. I will be covering chapter 4 reactions the end of this week / next weekend. So that's it for today. I will see you soon in a video for three-dimension analysis, a problem. Again, don't sweat too much about it. It's not that helpful, but I have to do it. I will sign off right now, and adios.